So what if the next giant leap in artificial intelligence wasn't some massive, super expensive new model? What if it was just one single line of code? It sounds way too simple to be true, right? But some new research shows how a tiny, tiny change can unlock a whole new level of creative reasoning in AI. Let's break down how it all works. Okay, so here's the deal. For all their amazing power, a lot of our most advanced AI models are kind of starting to plateau. When they're faced with really tough multi-step problems, their performance just levels off. Researchers notice they get stuck in what they already know, and they lose that spark to find totally new solutions. To get why this happens, you have to understand two basic ways of thinking. First, you've got exploitation. Think of a master chef who's absolutely perfected their signature dish. They can nail it flawlessly every single time. That's exploitation. Then there's exploration. This is the same chef messing around with new ingredients, new techniques, trying to create something brand new. Well, it turns out AIs have become incredible exploiters, but they're really struggling to explore. And that is the absolute heart of the problem. When an AI only gets rewarded for getting the right answer fast, it learns to just stick to the safest, most familiar path. It becomes that chef who only ever makes that one signature dish. This over-optimization means it just chokes when it sees a new problem that needs a creative leap, and its reasoning ability just stagnates. So, how in the world do you teach an AI to be more creative? Well, researchers found this fascinating clue, and it was hiding in the moments when the AI was most uncertain about what to do next. That clue is a concept called entropy. Now, in this context, you can just think of entropy as the AI's moment. It's really just a way to measure how uncertain the model is about what word or what step it should take next. Is it totally sure what to say, or are there a bunch of equally good options on the table? Think about it like a weather forecast. Low entropy is when the AI is super confident. It's like a forecast that's 100% certain it's going to be sunny. All its bets are on one outcome. But with high entropy, it's more like a forecast with a chance of sun, clouds, and rain. The AI sees a bunch of different ways forward, and none of them is a clear winner. And here is the big discovery. These moments of high uncertainty, these moments, they aren't a bug, they're a feature. Researchers found that high entropy popped up consistently at these super important reasoning moments, right before pivotal words like because or however, during reflective moments like when it decides, let me double check my work, and especially when it stumbled onto a rare, really creative solution. It turns out uncertainty was the signpost pointing directly to exploration. So, okay, if high entropy signals a moment of potential creativity, how do you get the AI to actually lean into it? Well, the solution they came up with is just beautiful in its simplicity. That's right, the paper itself calls the fix a minimal modification with only one line of code. I mean, that's just a powerful statement about finding a simple, targeted solution to a massive, massive challenge. Now, you don't need to be a programmer to get this. Don't worry. All this little line of code does is give the AI a tiny nudge. It basically says, hey, that moment back there where you were a little unsure, that was a good instinct. I'm going to give you a small reward just for even considering that exploratory path. Let's break it down. The process is really simple. First, the system spots those high entropy moments. Second, it gives a small temporary bonus or reward right at that step. And third, that little boost encourages the AI to see that uncertain path as more valuable and to explore it more deeply next time. And this is just a fundamentally smarter way of doing things. You see, older methods tried to force exploration by pretty much telling the AI, just be more uncertain all the time, which you can imagine is kind of chaotic. This new method is way more targeted. It gives a small advantage or reward to the AI for productively exploring the uncertainty that just naturally shows up, instead of forcing it to be uncertain all the time. So the theory is really clever and the code is incredibly simple. But does this one-line fix actually work? Well, the results are pretty dramatic. To put it plainly, the models trained with this new method showed a huge, significant leap in their ability to reason their way through complex problems. Okay, so check out this graph. It's showing performance on a really tough math test. The black line, that's your standard AI. The purple line is the same AI, but with that one-line entropy boost. Just look at how the purple line consistently pulls away, finding more and more correct solutions that the standard model just completely misses. And we can put a hard number on that. On this brand new, super difficult math challenge, the standard model scored about a 43. With the entropy advantage, it jumped all the way to almost 57. I mean, that is a massive improvement on a test that's designed to stump even the best models out there. So the numbers are impressive for sure. But what does this enhanced reasoning actually look like in practice? How does the AI's thinking actually change? Well, this is a real night and day difference. On the left, you've got the standard AI trying to solve a logic puzzle. It gets completely stuck in loops, repeating nonsense like correctly summed properties correctly would sum correctly, and, surprise, surprise, it gets the wrong answer. But on the right, the entropy-boosted model, it's like a different creature entirely. It's systematic. It says things like, let's start by trying small values, and let's try n equals 6 again with a different strategy. It explores, it course corrects, and it gets to the right answer. So the big takeaway here is that this one tiny change has some really big implications. It leads to AI that can do deeper, more structured problem solving. It gives us a new tool to break through those performance ceilings we were talking about, and maybe most excitingly, it fosters a more flexible, you could almost say curious, form of artificial reasoning. It's just a powerful reminder that the future of AI might not just be about making models bigger and more expensive. It might be about making them smarter in more elegant and efficient ways. It really makes you wonder, if this is what one single line of code can do, what's the next big leap in artificial thought going to be?